Okay, so I'm going to introduce about him. Dr. Beho Soni is currently serving as an assistant professor in the Department of Computer Science and Engineering at Maulana Azad National Institute of Technology, Manit, Bhopal, India, since 2020. He received his PhD degree in Computer Science and Engineering from Birla Institute of Technology, Mesa, Ranchi, India in 2019. His research spans ad hoc and wireless sensor network, machine learning, soft computing, and deep learning, with applications in intelligent system and healthcare monitoring. His work includes the design of energy efficient routing protocol and topology control mechanism for wireless sensor networks, deep learning frameworks for wearable sensor based human activity recognition and fault detection, and medical image segmentation. He has authored and co authored numerous peer reviewed articles in high impact journals, book chapters, and international conference proceedings. So, welcome, sir. Over to you, sir. Please. सर वॉइस ऑडिबल नहीं है आपका देखिए देखो तो नो सर योर वॉइस इज नॉट ऑडिबल
Is it audible now?
yes sir, audible sir, audible.
Okay, okay. Thank you, Deepak sir, for inviting me and organizing such a meaningful and wonderful short-term course. So, should I share my PPT first? Hello, am I audible?
Yes sir, audible sir. Yes
Okay,
sir, you
I'm
may
going
share
to
it,
share
sir.
I'm going to share my PPT first. Just give me a
Yes.
minute. Okay, is the PPT visible?
Yes sir, visible sir.
Okay, so if not required, can I turn off the camera?
Yes sir, you may
Okay,
sir.
okay, thank you. Okay, so again, thank you, Dr. Dilip sir, for inviting me and organizing such a meaningful short-term course on machine learning and deep learning in agriculture and biomedical engineering. Uh, As per the topic, I will be discussing on transforming intelligent healthcare through generative AI, and we will be discussing various prospects and challenges that we may face, we are already facing while developing, while working on such domain. Let's start with the basic idea of all these things. Let me start with a quote introduced given by one of the professor in Harvard Business Review. In Harvard Business Review, AI can not only boost our analytical and decision-making abilities, but also heighten creativity. In summary, we can say this quote highlights that artificial intelligence is useful not only for improving data analysis and decision making, but it can also offer various way of enhancing human creativity. AI can quickly process large amount of information, identify patterns, and support better decision in various areas such as healthcare, industry, business, as well as research that we all are interested in. At the same time, AI can assist in creative tasks like generating ideas, designing images, writing content, and developing innovative solutions. So nowadays, we don't really have to develop any sort of application. We can simply use some AI-based tools just for getting the same task. So in summary, we can say that AI acts as a powerful tool that supports both logical thinking as well as creative innovation. Uh, Uh, Let me start with the introduction of this presentation. So generative AI refers to a class of AI systems that can create new content such as text, images, signals, reports, codes, or multimodal outputs by learning patterns from existing data. So nowadays there is a possibility where we don't might have lot of large amount of data for the training perspective. So at that time we can take the help of AI just for creating all those data. So in simple term, we can say generative AI is a type of AI that creates content by first learning the patterns in existing data and then generating new content that follows those patterns in a similar manner. So we can say we can simply train our model in such a way it will start learning how gently or what sort of data we are looking for. And just by learning, it will start generating all those new content. And the generated new content will be very similar or will be very realistic that we really wanted to. So healthcare is a particular attractive domain for generative AI because it faces three persistent bottlenecks or limitations like limited label data. Nowadays, most of you are working on cancer detection, MRI images, CT scan images, but at that time you can face a problem where the availability of data that you actually need for training your AI model is not that much. So at that time we can take the help of generative AI. Sometimes the available experts are there, but the time is not there, right? And they might cost a lot just for giving their time. So expensive expert time might be there if you're really going to hire some expertise. And a strong need for personalization is also required because there is a possibility where you can have your own aspect of designing that model. So at that time, personalization can also be a very challenging aspect. So generative models can help fill missing modalities, synthesize realistic training examples, draft, and support clinicians with context-aware assistance. So I'm not going to get into it because a lot of people are working on the same domain. So we can see generative AI as a subset of deep learning, and further other subdomains have been introduced, but we are not going to get into that as of now. So again, there is another plot that shows how much we have moved since the formation of AI. So how generative AI works? So generative AI models utilize advanced architectures and training approaches to produce outputs that appear realistic and meaningful. The fundamental operation of generative AI consists of three distinct steps. The first thing is data collection and training. So at that time, we always offer huge amount of data set like text, images, or audio to the model. And after that, the model will be analyzing all this data just for understanding the pattern and structure, and as well as their relationship. After that, it will go into the next field, which is next step, which is feature extraction. So the AI model analyzes data to identify crucial features that reveals its basic characteristics. As you know, in machine learning and deep learning, feature extraction is very important because if you are able to highlight some important feature that can actually influence the overall performance of your AI model, it will somehow impact the overall performance of your deep learning model as well. Right. The next step is model learning. So through deep learning techniques, the model acquires the ability to create content similar to its training data, yet remains coherent and logical structures. So learning is very important so that you can train the model as per the given input. After that, the content generation can be treated as the outcome. So the model will start generating new outcomes based on its learned pattern. Whenever it receives a prompt, like most of you are using ChatGPT nowadays, right? But when you start giving some input, at some point you might not be getting the expected outcome. But while training your ChatGPT model, you will start getting some sort of you will be getting your outcome, which is really expected from your end, right? But at that time, you have to keep asking the ChatGPT until unless it start giving the expected solution or the answer, right? So it is nothing about the learning. But in ChatGPT, we don't really need to train the model because it has already been trained with large amount of data. But at that time, ChatGPT has to handle in such a way it will start giving outcome based on your specific solution, right? Or problem. So after that, the next step is fine tuning and optimization, which is always there because at some point, even if the model is very well trained, it might not be giving the best possible accuracy. At that time, we can get into the fine tuning operation so that we can still improve the performance of the model. Because even if your model is working good or as per the expectation, there is still a possibility of optimizing the model by fine tuning some of existing automation tools. So there are some things like there are three different editions of generative AI, like LLM, SLM, RAG versus AI agent. So these are the generative AI models. Those are being used in the text field, right? So large language models are a powerful form of this AI generating human-like text, while small language models focus on specialized tasks with less data. Suppose if you're using ChatGPT, it will be the part of LLM. But suppose if you are a doctor and if you want to use some specific tool that will be answering all medical fields entries, so at that time it will be considered as small language models, because that model will be trained only for handling all the problems related to medical fields, right? The next thing is retrieval augmented generation, which is also known as RAG sometimes, enhances these models by pulling in external information for accurate results. So there is still a possibility where you might be working on the RAG kind of models, right? After that, the AI agents use generative AI to autonomously perform tasks such as writing or research. Nowadays, you might have heard like China is working on various AI-based models where they can start generating different AI agents in order to handle multiple tasks at the same time, right? The very first application is text generation. So text generation involves using machine learning models to generate new text based on patterns learned from existing text data. So the main application that I already mentioned is ChatGPT, which was developed by OpenAI, which is nothing but the open source no fund, it is open source platform, and they are working in this particular field for the last couple of years, right? And almost everyone else are using ChatGPT nowadays in various perspective. The next thing is image generation. Most of us also using some sort of app in order to generate some AI-based images. So it use some real-based models like VAE, GAN, diffusion-based models just for creating some real-world or animated images, right? So image generation can be used for data accommodation to improve the performance of machine learning models, as well as in creating art, generating products, images, and more, right? So there are a number of applications are available in the market like Midjourney and Dolly. And just by giving the specific prompt, you will be able to generate some AI-based images, right? But you must have heard of prompt engineering. So at that time, you have to be expert in the prompt engineering field so that you will be able to generate an image that you actually wanted. Nowadays, you might have heard like various people have started generating some short videos by using the help of AI, right? So video and speech generation is another application of generative AI, where we can give some specific set of prompt, just like a narrative script, so that it will be able to generate a video or audio. Nowadays, you might have heard just by giving an input of a book, it will be able to generate speech as well, right? I can also summarize the overall book just in one paragraph. So there are a lot of AI-based models available in the market for different perspective, right? Data combination is also another application or field where generative AI can actually play a very crucial role. Data combination is a process of generating new training data by applying various image transformations such as flipping, cropping, rotating, and color generating. So most of you are working on the field of image object detection or segment. At that time, you might not be getting the expected result because of the availability of the data for the training prospect. So at that time, what you can do, you can generate some duplicate data, right? But at that time, you will be applying some of the data combination based techniques, right? Because the model will be working, will be some of the overall performance of the model will be depending on the number of inputs. If the amount of data is large, it will also be able to perform in a good way, right? So the overall goal is to increase the diversity of training data and avoid overfitting, which can lead to better performance of machine learning based models, right? So there are some online applications, applications are available like Synthesis AI, which can give you a platform for creating AI-based models using automated machine learning techniques, right? So at that time, you don't have to worry about the specific text. You can simply ask what sort of data combination you want to apply, and based on that, it will start generating some augmented data for the same perspective. Now, the next thing is type of generative AI models. So there are various generative AI-based models like LLM, right? LLM, GAN, VAE, diffusion model, RNN. So here, let me start with the transformer model. So transformer models are a DL architecture designed for processing sequential data such as text. They use a self-attention based mechanism that you might be aware of. If you don't, you must get into it, because attention is one of the mechanisms that is being used almost everywhere. So in continuation, they use a self-attention mechanism to understand relationship between words in a sentence, in efficient handling of long-range dependencies. So these models are trained on massive data set that can generate coherent and context-aware text, right? So for example, Chat GPT, a chatbot, text summation, AI-powered search. The number of applications available are there. And some key features can be like, and it can handle long text equation efficiently, supports parallel processing during training. It can learn contextual meaning of words, or it can also be very high level. It can also be highly scalable, depending how much data you have used for the training purpose, right? So the next type of model is GAN, generative adversarial network, and most of you must be aware of this model as GAN only, right? So GAN consists of two main neural networks. The first one is the generator, and the another one is the discriminator. So generator is mainly used for creating new fake data samples. On the other side, a discriminator identifies whether the samples are real or fake. So whatever images have been generated by the generator will be classified as real or fake through the discriminator. We will get into it in detail in coming slides. Okay, so both networks are trained together in a competitive manner, improving the quality of the generated outcome over time. And the main features can be considered as, it can produce highly realistic images. It can be useful for data computation based tasks. It can also be very effective for image synthesizes, right? So the next one is variational autoencoders. Sometimes it, in short way, it can be referred to as VAE. So we are probabilistic generative models that can learn compressed representation of data called latent speech recognition. They generate new data samples by sampling from the latent space, right? And the main features can be like, it can learn meaningful feature representation. It can generate a smooth variation of data. It can be more stable, more training than GAN. So sometimes it can perform better compared to GAN depending on the specific application. So the next type of model is diffusion model. And diffusion models generate data by gradually removing noise from random inputs until a realistic sample is produced. So at that time, it will keep working on the same task, right? Until and unless the realistic sample will start producing. So these models have recently become popular for high quality image synthesizers. So nowadays, most of you will be working on the diffusion-based model, where you will be able to generate some very high quality image synthesizers. And the main features are, it can generate high resolution outputs. It can produce stable and diverse samples. It can offer better training stability than GANs. And it can be different. Okay, that is fine, right? And the next type of models are RNN or STN that I have already mentioned, that you must be aware already, right? Moving to the next slide, LLM. So large language models are advanced AI systems trained on massive text data set to understand and generate natural languages. For example, include GPT-based models that I have already mentioned multiple times in previous slide. So these models rely on the transformer architecture. That is what one of the most popular architecture that most of you are already working on. So transformer are various variation of transformer is the current highlight by most of the researchers, which can be used as an attention mechanism to capture relationship between words and in a sentence. So this allows the model to understand context and generate coherent responses. So LLMs are capable of performing multiple NLP-based tasks, including text summarization, question answering, translation, text classification, clinical documentation generation. Nowadays, suppose if the entire research paper is given to you, you can simply give this as an input, and after after uploading your research paper, you can simply start asking the question, and the answer will always be related to the uploaded research paper. So if you are a good researcher, you will be able to ask some good and relevant question, right? So ultimately, it will be your responsibility how you will be able to exploit its functionality or the features offered by that particular model, right? But one major advantage of LLM is their ability to perform many tasks without requiring additional training because it has already been trained. So before coming to the market, all these companies already train this model by large amount of data so that no further training will be required. You just need to start using that model directly, right? The next kind of model is generative adversarial network. As I already mentioned, there are two neural networks. The first one is generator, which will be responsible for creating synthetic data samples. On the other side, distributor, which will be determining whether the data is real or generated. So the two networks compete with each other in a training process called adversarial training. So that's what is known as GAN, adversarial networks, because these two networks will keep competing with each other so that the overall performance can be improved. The generator continuously improves its ability to produce realistic data, while the distributor learns to detect fake data. At that time, both the neural networks will be training themselves, so that generator will start generating some fake images. Those will look exactly like a real image. On the other side, distributor will keep training itself in such a way it will be able to uh, identify any fake image which is not actually real. So at that time, both the networks will be competing to each other, right? And the various applications of GANs are image generation, medical image reconstruction, data accommodation, image segmentation, and classification. Nowadays, you must have heard, like most of you are working on the image segmentation based tasks. At that time, we can take some input from the medical field data set, where it can be offered by some specific research group. At that time, you can simply take the help of GAN just for creating some fake images, right? If the number of data set is not that large. Okay. So in healthcare, GANs are particularly useful for generating synthetic medical images and improving the performance of diagnostic systems. There are some others that I have already mentioned in brief, but we are not going to get into deep for all those models, right? So if you have any interest to any specific problem statement, you can simply get into those. Okay. So let's come to the applications of generative AI in various fields like innovation. So rapid prototyping, creative content generation, scientific discovery, product development, right? So you must have heard of, like in earlier days, it used to take almost 5 to 10 years just for creating new sort of medicine, right? But nowadays, with the help of GAN, the same task can be completed just in months. So it is only because of the help. It is only because of the advancement in deep learning, right? So it has helped lot to medical scientists for performing the same task in less time, right? So there are various fields where the generative AI can play some important role, right? So for personalization, custom content, adaptive learning, healthcare, entertainment. Nowadays, if you're using WhatsApp, you don't have to write the whole message. AI can help, right, in order to complete the message. Now, suppose if you're receiving any email to your email ID, at that time you don't have to write it manually. So based on the input, you can simply ask the AI to ready the reply, right? So it is nothing but the use of generative AI, which will somehow be able to handle all these tasks automatically, right? Healthcare is another field. Like at that time, nowadays, suppose if you are if you have been diagnosed with some specific disease, or if you're looking to in some specific what report, at that time AI can help you. So based on your body structure, based on your diet, based on your diagnosis, it can recommend you some sort of diet, right, that you need to follow. So it is nothing but the use of generative AI. Even in the field of entertainment, adaptive storylines or visuals in games to match user preferences. Nowadays, just by playing one song, you can start listening to some other related song which can also be likened by the same person, right? So AI is being applied to almost every field of our life, right? Starting from research, industry, uh, medical, to your entertainment or personal things, right? Let's come to the automation. So content creation, customer support, code generation, document processing are some of the fields where generative AI can be very, very helpful. So content creation, assisting, creating with brainstorming through image generation, video editing, and more. So nowadays, just by giving some sort of prompt, you will be able to generate some sort of video, right? So customer support, assisting human agents in handling inquiries, a chatbot help customer resolve issues and escalate them if they cannot. So at that time, you don't have to hire any specific customer support person. So AI can take over all those kind of tasks just by keep asking queries by the user end. And based on the input given by the user end, it will be able to provide some sort of help, right? Code generation is another field. If you remember, nowadays you don't have to worry about the code thing, right? You can simply upload the code and ask for the help, right? You can check whether you can what exactly you want to add to the existing code, and AI can help you, right, in order to generate the code that you actually wanted. Document processing another thing. So nowadays it has already reduced the overall task of the data scientist. So data set can easily be trained, or the data set can easily be what analyzed with the help of generative AI, right? So some other fields in healthcare, like synthetic data generation. So healthcare research often faces challenges related to data privacy and limited data availability. Data privacy means, like, suppose if you are a patient, right, and you have been diagnosed by any specific disease, you are always ready to give the best possible medication, but at the same time, you might not be interested to share your data, right? Or suppose if you are working as a member of the hospital, so hospitals are always intended to offer the best possible services to their patient, but at the same time, they don't want to share those information with any other hospital, because some other hospital can start offering some better services. So at that time, data is a thing entity which can be either public or private. But in various fields, it can be considered as a private entity, right? So at that time, AI can actually help you. There's another possibility, which is data, unlimited data. So nowadays, suppose if you remember the situation of COVID in the beginning, the government were not able to find the exact solution of the COVID, because they don't really have any sort of input so that they can start developing any vaccine. But in by time, they started collecting a lot of data, and based on those data, they really help government to develop the related the effective vaccine. Those can be offered to their public, right? So data is also very crucial, but especially in the field of healthcare, the most of the times data will be limited. But this availability of limited data can be overcome by the help of generative AI, because generative AI can help you to generate some augmented data, synthetic data, okay, just for the training purpose, which can further improve the overall performance of the deep learning based models. The next field is drug discovery. As I already mentioned, in the earlier days, the medical scientists used to take almost 3 to 5 years just for developing a new and challenging kind of medicines. But nowadays, with the help of generative AI, they are able to perform the same task just in months, right? Because they are able to perform or process all these data in very less time with the help of generative AI, right? So this approach significantly reduce the time and cost involved in training in traditional drug discovery process. The next application is medical diagnosis. So generative AI models can analyze medical images and patient records to identify patterns associated with diseases. For example, GANs can generate synthetic medical images for training diagnostic models. LLMs can analyze electronic health record and summarize patient information. So these capabilities enable clinicians to make more accurate diagnosis and improve clinical decision making. So here we can take the help of both GAN as well as LLM. for different perspective. So GAN can be applied to images. On the other side, LLM can be applied to all the records collected from the patient, right? So personalized medicine. So nowadays, as you know, drug can be very specific. Any specific drug can be very effective to one person, but cannot be effective to any other person. So at that time, it will be working. It will be depending on the DNA sample, right? So generative AI enables personalized healthcare by analyzing patient-specific data such as genetic information, medical history, lifestyle factors. So using these information, AI systems can predict how a patient may respond to specific treatment and recommend personalized treatment plans. So nowadays, just by having some limited data, the generative AI can actually work on these kind of problem statements. The next application is clinical documentation and administration, right? All these applications are related to healthcare field. So healthcare professionals spend a significant amount of time on administrative tasks such as documentation and record management. Generative AI can help automate these processes by generating patient summaries, clinical reports, discharge summaries, medical documentation. So even today, if you are going to be discharged from any hospital, it takes almost 6 to 8 hours just for finalizing the document. But with the help of generative AI, the same task can be performed just in minutes. Right? At that time, you might not have to wait for 6 to 8 hours just for getting discharged from the hospital, because everything will be prepared automatically with the help of generative AI. Even though the most of the healthcare sector have not adopted this kind of features offered by the generative AI, but in the coming years, they will definitely start taking the help of generative AI to perform the same tasks, right? Then medical education and training. So generative AI can also improve medical education by generating virtual patient scenarios and simulated clinical cases. These tools allow medical students to practice diagnosis and treatment planning in a safe environment. Because if you remember, if you know, the overall practice of the medical student depending on their exposure, whether they are able to find those kind of patients, whether they are able to treat those kind of patients, then only they will be able to train for those kind of diseases in a better way. So at that time, we can generate some synthetic data in order to train all those students so that they will be able to handle realistic scenario whenever they become doctor, right? So AI-based education system can also adopt to the learning pace of individuals like students, providing personalized learning experience. There are some specific applications in healthcare like brain tumor segmentation, and most of you must have heard of brain tumor segmentation. And if any one of you who is already working in the field of object detection and segmentation, this is one of the common problem statement that you can start with, right? If you really want to get more exposure in the data image segmentation field. Generative AI can help overcome limitation of a small medical data set, and the application can include like MRI image reconstruction, CT denoising, synthetic pathology images, and tumor segmentation support. Nowadays, the research shows that the generative models can improve brain tumor segmentation accuracy by synthesizing missing MRI modalities. What does it mean? So in the MRI images, the overall images can be grouped into different modalities, and for a better deep learning model, you will require the same amount of images in every single modality data set. But in sometimes you might not have the same amount of data for those kind of modality subset. So AI can help you to generate some synthetic data, and somehow it will be improving the performance of the deep learning model, because it will be able to train in a good way by with the generated synthetic data set. Let's conclusion into that. The basic problem is considered as MRI scans may lack certain modalities like FAIR, T1, T2. There are 5 different type modalities in brain tumor segmentation. So there is a possibility where you cannot have a good amount of data set for these kind of modalities. So you can take the help of generative AI to missing these sequences. So the overall benefits will be improved segmentation performance, better model generation, and reduce data acquisition cost. In condition to healthcare application, it can also be used in wearable sensor healthcare, uh, where we can use different kind of sensors in order to collect different type of inputs like accelerometer, gyroscope, or heart rate. So these signals are used for human activity recognition, fall detection, sleep monitoring, rehabilitation tracking, and here we can face various challenges like real fall detection. Real fall events are rare because most of the times you will not be falling all by sudden, right? So at that time the possibility of fall is very rare. So at that time you can take the help of you can take the help of generative AI to detect the possibility of fall, right? So that the model will start working in a good way to detect any possibility of fall even before it happens. So most data set contains simulated falls. Then the simulated falls means some of the activities can be classified as false, even though it is not actually a fall, right? So generative AI can be used to generate synthetic false signals to balance data set, so that the model will be able to perform better by considering all those synthetic data set in order to perform in a better way. Uh, there are other fields like data accommodation, personalized medicine, remote healthcare, and medical training. So all these some application in the field of healthcare that you can consider in order to take the help of generative AI. And depending on your interest, you can start looking to some specific problem statement that you really want to work on. The interest will be totally up to the researcher whether they want to work on the image-based data set or the time series-based data set. After that, they are strongly recommended to learn some survey-based paper so that they will be able to understand the overall problem statement and the related papers and the data set they can start with, right? Then there are some evaluation metrics that you can consider in order to evaluate the generative AI-based models. The first one is peak signal to noise ratio. It is also referred to as PSNR. So PSNR measures how close a generated image is to the original image. And here, the higher PSNR means better image quality and less distortion. So if you are able to get a value which is, if you are getting the value of PSNR close to 1, it means you are able to generate a very realistic image. And you will always try to keep it high as possible. The next one is SSIM, which stands for Structural Similarity Index Measures, and it checks the similarity between two images based on structures, brightness, and contrast, right? So here, if the value is close to 1, it means it is a very good or better quality picture, right? Again, you will always try to keep it close to 1. The next one is FID score, and it measures how realistic generated images are compared to real images. And here, the lower FID scores indicates better image generation quality, right? So unlike PSNR or SSIM, you will always always try to keep the value of FID as low as possible. The next one is segmentation. So in the field of segmentation, there are some standard metrics that you can consider, like dice coefficient. And here, dice coefficient measures the overlap between predicted and actual segmented regions. And here, the higher value indicates better segmentation accuracy, right? And there is a known formula that you can consider to determine the dice score, right? And you can get into that, right? So the next one is IOU, which is also stands for known as interaction over union. So IOU measures the ratio of overlap to the total combined area of predicted and actual region. Again, the higher IOU means better segmentation performance, right? Just like that, some other prediction metrics that you can consider like accuracy. So accuracy measures the percentage of corrected prediction made by the model. Precision refers to how many predicted positive cases are actually positive. Recall measures how many actual positive cases are correctly identified. F1 score combines precision and recall into a single measure. On the other side, AUC or ROC curve measures the ability of a model to distinguish between classes. So higher AOC values indicate better prediction performance. So all these performance metrics that you can consider in order to check the correctness of the model based on these parameters. So depending on the field or depending on the data set, either you can use PSNR, SSIM, or FID if you're working in the field of image generation. You can use die-score or IOU if you're working in the field of image segmentation, or you can use accuracy, precision, recall, F1 score, IOC if you're working on the time series space test problem statement. So somehow the performance metrics will be depending on the problem statement you're working on. Now let's get into the basics of generative AI. GAN. So GANs are a class of I have already mentioned a lot about GANs already. So let's come to the block diagram. So here, as you can see, there is an input vector, then generator, then fake generator sample, then real samples, discriminator, and classification real or fake. So just give me a minute. Please open. Okay. So as you can see, input vector is nothing but the random vectors that can be offered to the model. The next one is the generator, and the main responsibility of this generator to generate some fake images. And these fake images are supposed to look like a real image, right? After that, it will start offering some fake images samples, right? Which will go through the discriminator. So the main task of discriminator is to compare these generated fake images given by the generator with the samples offered by the real images, right? So here the discriminator will be comparing the real images with the fake images. And if it finds any differences between the real and fake images, it will be able to classify that image as real or fake. So if the discriminator is very well trained, or if the generated fake images are not very good, which are actually looking like the real images, the discriminator will easily be able to classify those images as fake images. So as I mentioned, these two neural networks, the first is generator and the discriminator, will be competing to each other. And both the neural networks will be training at the same time, all together. So here, at some point, generator will start producing in such a way the generated fake images will look like very real images. At the same time, discriminator will not be able to identify any difference between the fake images and real images. So at that time, as you can see, if the discriminator is not able to identify that image as a fake or real, or it is classified as real, it means the generator is working in a good way, right? So the overall task of the generator is to generate fake images those looks like a real image. On the other side, discriminator will be used to find any difference between the generated fake images and the real images, so that it can simply classify them as fake, right? So this is the overall architecture of the GAN. So why GAN matters in healthcare? In healthcare, GANs have become especially important because medical data are often limited, that I have already mentioned. And sometimes it can be very expensive to annotate. It means the labeling thing, right? And sometimes it can also be highly imbalanced. It means you cannot have the same amount of data for in different classes. So sometimes it can be very imbalanced. And sometimes it can be timely restricted for privacy rules. Sometimes most of the data might not be available to you, right? So the GAN can help you with a small data set. It can reduce the possibility of class imbalance. It can support privacy preserving data sharing. It can improve image quality and downstream model performance, and it can also be useful for training, simulation, and research prototype. Right? So GAN can actually be very helpful in such problem statement where the amount of data is less, where there is high imbalancing in the data set, imbalancing in different classes, and where the annotation task can be very expensive and time taking. So let's take one real application of the GAN. As you can see, there is a generator, right? And there are some set of fake samples generated by the generator, and this computer will be able to classify whether it is fake or real. If it is fake, only the 0 value will be assigned to that. If it is 1, the 1 will be assigned to that. right? And it is based on the idea of backpropagation overall. So as you can see, here you can see the number of fake images generated by the generator, and by increasing the epochs, the quality of the fake images will start looking like a real images, right? So you have to train the model in such a way it will start generating images those actually looks like a real image. So as you can see on the top of the figure, the epochs is being starting from 1 to 100, right? And by time the generated fake images will look like a real image, and that is the overall task of the chain, so that the generated fake images will look like a real images that can further be used for training our model. As you can see, I have taken samples. Actually, this particular slide has been taken from some other resource, and there are some specific outcomes after running the model at different epochs, like epoch 1, epoch 5, epoch 10. And as you can see, as long as the epoch is being increased, the quality of the image is also being improved, right? So here it shows the evolution of the synthetic images generated by the generator, right? And over the time, the quality of the peak images are being improved. Even if you continue with that to 200 or 300, it will start look a very high quality images. At that time, for a human person, it might not be able to easy to identify whether it is actually fake or real. So these images can further be used for training our model to be considered as a specific class where the amount of data is not that much. So as you can see, these are some of sample of the real images, and these are sample of some generated images by the generator. So here you cannot find much difference between the real and fake images. This is the overall process, right? Then the challenges that we can face in generative AI. The very first challenge is reliability. So generative AI models may produce inaccurate outputs. So because somehow the overall performance will be depending on the outcome generated by the generator. And suppose if you are not able to generate some very good outcome through the GAN, it will also affect the overall performance of the model. So at that time, it will not be working accurately as per the expectation. The second thing is misleading clinical information, because sometimes your data can be biased, and if the data is biased, the overall training of the deep learning model will also be misleading. So at that time, it might not be able to get the provide the expected outcome, right? So healthcare requires very high reliability, right? We can any possibility of mistake can be very harmful for any specific person, right? If he is being diagnosed by some very a crucial disease like cancer, right? So data privacy is another challenge, because medical data set contains sensitive information, and the leakage of information of any information of any specific patient can be very, very crucial, right? So the possible data leakage is always there. So there's another challenge where you need to maintain the privacy of any specific patient, and if the patient is not supporting, at that time you cannot consider that protocol. You never want to get into that protocol problem, right? And for that particular purpose, pattern learning based idea can be adopted, right? A secure training can also be adopted. So these are some possible solutions in order to handle the possibility of data privacy, like pattern learning, referential privacy, or secure training, right? So here the model will be trained in such a way there will not be leakage of information, there will not be any possibility of data leakage. Okay. The next one is the ethical concern. Important ethical questions include like, who is responsible for errors? Can AI replace physicians? How transparent are AI decisions? Right. So all these questions are always comes in your mind. Right. So here we cannot get it free. Right. We have to limit some boundaries. Right. So while developing all these models, we had to decide who is actually answerable to all those things. right? And as long as the ethical responsibilities are not decided, we cannot simply let it free. Then regulatory barriers, like healthcare technologies must pass strict regulatory approval, and the challenges can be like clinical validation, safety certification, or accountability. Accountability is very uh, important regulatory based concern, right? The next one is generative AI translation path. Just give me a minute. If you have any question, you can ask. Hello, I'm still audible.
Sir, yes, sir, you are audible. Yes.
Yeah, if you have any doubt, you can ask.
Yeah, so no questions, sir. You can continue as of now.
Okay,
Okay, sir, sure.
thank you. So this figure illustrates the generative AI translation path for successful integration of generative AI in healthcare. Generative AI can also be referred to as Gen AI, right? In short. Right? So the very first uh, thing is acceptance and adaptation. So awareness and education among healthcare professionals, stakeholders, help increase trust, acceptance, and adaptation of generative AI technologies. Because nowadays, any specific person can start working on the field of generative AI, but that person might not be know what actually he is working on, and if he is trained well, or if he is being offered with a good training, he will be he will be able to handle the accountability. He will be able to be answer. He will act as an answerable person, right? Because he will be knowing what exactly is being performed by the generative AI. The another aspect is data and resource. The high quality data, computational resource, and proper data preparations are some essential field for effective implementation of generative AI system. Because the overall performance somehow depends on the data. Here, generative AI will be generating some synthetic or fake images, right? Synthetic images. And the available data is not good, or it is not high quality data. At that time, the generated synthetic images will also not be that good. So as a student, whenever you are going to appear in any examination, somehow the answer will be depending on what sort of book you have referred. If you referred some good quality book, at that time the answer will also be very good. But if you have referred some notes just for preparation, your answer will also be depending on that, right? So overall, the quality of the answer will be depending what sort of resource you have considered for the preparation purpose. So this is why the availability of data is very important. And during for the training perspective, the high quality data must be offered so that the generated synthetic data will be as good as real and high quality data, right? The next important aspect is technical integration. So successful integration requires compatibility with existing healthcare infrastructure, workflow, and organization requirement. So here, if you're working as a faculty, or if you're working as a teacher, or if you're working as a researcher, so somehow uh, the performance will be depending how good workstations are being offered to your institute or organization, right? So the availability of hardware support is also very important. The next aspect is governance. So proper governance ensure ethical use, privacy protection, security, and risk management while deploying generative AI in healthcare. So nowadays you must have heard many people have generated some fake images, right? They have started these apps for creating some fake video posts, right? Or even the images. So nowadays, recently, government has decided to mention some sort of idea so that they will be able to detect whether that particular image or video is AI generated or not, right? So we have to mark that image or video as a fake or real, right? So that there will be some specific difference between the real and fake images. In conclusion, disconnect. Generative AI represents major technology advancement for intelligent healthcare systems. By enabling generation of realistic synthetic data, enhancing medical and image analysis, and supporting personalized healthcare, generative AI-based models offers powerful tool for improving medical research and clinical practice. However, significant challenges such as reliability, ethical consideration, privacy protection, or regulatory approval is always there. And some specific body must decide all these regulatories, right? Obviously, the government bodies are mainly responsible for all those kind of regulation, but they must come up with this idea. So, successful adaptation of generative AI in healthcare will require careful integration with clinical expertise, regular validation, and responsible governance. So, that's all from my side. If you have any doubt, you can ask. Or if you have any doubt, if you have any query to any specific
Sir,
slide, I can also switch to that broadcast slide.
yeah, so there was a question on how to use federated learning to secure training data in GAN. Someone has asked this.
See, uh, GAN is a different field. GAN and federated learning are not directly related to each other, but federated learning is one of the aspects where the privacy can be preserved. So what happens, suppose if you're working in your institute, right? I'm working here. So sometimes if you really want to improve the overall quality of the performance of the model, we always be interested to share our data so that the overall performance of the model can be improved in a good way, right? But suppose if that raw data is private to you and you don't want to share it to be with me, at that time I will not be able to train a model with your data, right? So at that time, federated learning is one of the field in deep learning where the model can still be trained without sharing the actual data, right? So what we can do, I can come up with the very standard model, and that model will be trained in my own system, considering my own data, and the same model will be used to train in your system, considering your data, right? And instead of sharing the data, only the metrics will be shared, right? Or whatever metrics can be useful to overall performance of the network, right? So federated learning is a very good it has started it got introduced somewhere around 2021, right? And it has been introduced to maintain the privacy that so that you don't have to share your own data with any other person. So at that time, you can simply you can simply derive the concept of clients, where different clients are trained at the same time with their own data set, right? And at the end, whatever model is working good will be shared among all those clients.
Okay, so any other questions? So if any one of you have any questions, you can ask now. So okay, so if none of you have any questions, so let me thank the speaker. Sir, thank you, Dr. Vaibhav, for such a wonderful presentation. Clearly highlighting the applications and challenges of generative AI in healthcare. So we would like to again thank you once again for agreeing to be for agreeing to deliver such a lecture, a wonderful lecture as part of the short-term training program. Thank you, sir.
Thank you so much. Thank you so much. And thank you for inviting me again.
So I think someone has a question. They have raised their hand. So you can go ahead and ask your question if you have. So someone has raised their hand. If you have a question, please.
Please ask the question if you have any. Yeah.
Okay, okay. So, sir, you can please stop sharing the screen. So we'll take a
Okay.
photo. So,
Sure, sure. Okay.
sure.
Just a
Yeah,
minute.
yeah. So, sir, give me 2 minutes. Dr. Dilip will be arriving within 2 minutes. Yeah. So
Okay,
we'll.
sure.
Sure, sir.